In this cast, we're going to be looking at the different types of motion, as well as how to describe it using visual motion diagrams. So there's four basic types of motion. Of course, any one type of motion has a combination of these, okay? But, in the most basic sense, we have just things going up or down or left and right, okay? That's straight line motion, and that's what we're going to be focusing on in the first chapter. But we can also have circular motion, like this moon going around the Earth, around this trajectory, okay? So this is called a trajectory. We could also have projectile motion, like when you throw a basketball into a hoop, okay? It moves with projectile motion. And then one that's sort of different from all of these is rotational. And the reason it's different is because all the other ones, the object is actually moving, so it's changing position through time. Whereas this one, if you have a figure skater rotating, it's actually not changing position, it's only changing orientation. Okay, so this is something a little bit more complicated, but we can also look at a little bit later on. Now, when you talk about motion, you have to think about, who is moving? Who is moving? So it's important to describe this first. For example, here, if Tom sees Al and May moving on this truck, okay, Tom would say that Al and May are moving. But if Al looks at May, Al would say that May is not moving because she's always right there, standing that same distance from him. So the question of who is moving, okay, depends on the point of view. It depends on the point of view. And this point of view is what we call the frame of reference. Frame of reference. Visually, or normally, it's it's usually the Earth or a still camera Okay, so it's really important that the camera is still, because if the camera was moving with the person, then in that point of view or that reference frame, the person wouldn't be moving. Okay, so let's say we did have a still camera and we took 4, snapshots of this person on a unicycle moving to the right. Well, each kind of film strip would look like this. Okay, so these are still frame images. Okay, now in order to visualize this, what we do is we make a composite. Okay, so we layer them on top of each other to get a motion diagram. So this is a motion diagram. Okay, now because we're just starting with basic motion, we're not really concerned about the details of the person. Okay, so this person has a shape which would affect the motion, but for now we just want to simplify things. Okay, and so to do that, a simplification of a motion diagram is what we call the particle model. Okay, it's basically we're taking the entire, we call a body, okay, and we represent it as just one point in space. Okay, it's as if the point represents the entire mass of this object as a single point. Okay, now if on a motion diagram you can see here that these guys are equal distance apart. Okay, just like over here, these are equal distance apart. Equal distance. When that is the case, you can probably imagine that this person would be moving at constant speed, because between each time interval, okay, they move the same distance. Okay, and it's very important to also note that the time between each shot must be the same, otherwise this thing wouldn't work. Okay, so if the distance between each snapshot increases, so this is increasing distance, okay, then the person would be increasing its speed. Okay, and here in this case, the car stopping, you can see it's decreasing distance, so it's decreasing speed. Decreasing distance is decreasing speed. Okay, another little note, you can see that each of these frames have a little number. Okay, this is really important as well, so that you know where the frames start and where the frames end.